Hello boys and girls, we are going to discuss computer hardware at grade 11 level. The content will be the motherboard, the purpose and role of cache memory and caching, memory as part of a computer system, and computer performance. Now these are the concepts done in grade 10 which we will review. One is computer hardware, that refers to the physical components that make up a computer. Input devices allows you to add data to a computer, like a keyboard, mouse, camera, microphone, that allows you to enter data for the computer. Memory, this is the storage space in the computer where data is temporarily kept. So memory is temporary. So data that is being processed is kept here. Output devices takes data from the computer and makes it available to the user in a way that the user can understand. That is, for example, through monitors, speakers, and printers. That's your output. Your storage devices stores data permanently. The different storage devices like your hard disk, your CDs, and flash drives. And each one stores different amount of data. There are more storage devices and all store a different quantity of data. Processing devices, there's two. One is your CPU and your GPU. Now, your processing devices are responsible for executing instructions and performing calculations. Your CPU, your central processing unit, is found on the motherboard, and your graphical processing unit, GPU, may be found on the motherboard or on the graphics card, depending on your computer. Communication devices such as modems and routers allows a computer to connect to other computers on a network. Looking at the motherboard, the purpose and role of the motherboard is a large printed circuit board with specific slots for every hardware component. So your hardware components all connect on the motherboard. Your function and tasks of the motherboard: one, it provides the physical structure for the other hardware. It connects the hardware by putting in the hardware, your CPU, your RAM that is connected via the motherboard. And the motherboard provides power to the hardware and sends signals between the hardware. It allows you to send signals through buses. Your BIOS chip, this is found on your motherboard. These are some of your components. One is your BIOS chip. A computer's BIOS, which is your basic input-output system, is the first set of instructions that run every time a computer is started. So every time the computer is started, we run the BIOS. It is stored on the computer's ROM, which is your read-only memory. And it is responsible for making sure your computer starts up correctly. There is the BIOS application that can be accessed by users, where we can specify your hardware settings to the motherboard. Your CPU, central processing unit, is the most important component of the computer. It is the brain of the computer, and it runs all programs and processes, all software. Every application makes use of the CPU to collect, decode, and execute instructions. Now, your GPU is responsible for processing instructions that create pictures on your screen. For example, rendering 3D games, they rely heavily on GPU to create their images. Your RAM, random access memory, is short-term memory, which can store and retrieve active programs and data at high speed. So RAM is fast memory compared to your hard drive. Your RAM is fast memory, and it's electronic memory, and it can store and retrieve active programs and data. Now, when we say store, we mean temporarily store. When your computer is switched off or there's no power in your computer, the information in RAM is lost. So all data is erased from your RAM when your computer is turned off. This concept is called volatile. Your RAM is volatile because data is erased when it is turned off. VRAM, that's video random access memory. is memory used to store image data that the computer displays. It acts as a buffer between the CPU and the video card. When a picture is to be displayed on the screen, the image is first read by the processor and written to VRAM. That's video random access memory. ROM, read-only memory, it stores the motherboard's operating software called the BIOS. So BIOS. Here's your motherboard and here's the slots. There's your power. Power connection connects the motherboard to the power supply unit, which connects to a normal household power outlet. So there's a power supply unit that's connected here. That brings power to the motherboard. Now these are called DIMM slots. They're different colors. So we have colors here. Now the DIMM slot is used to connect the computer's RAM to the motherboard. That's where your RAM fits in. So in upgrading, we can add more RAM to your computer if there are DIMM slots available. Your CPU, this is your CPU socket. CPU is placed in a ZIF socket. So ZIF socket hosts the CPU. It is used to connect the CPU to the motherboard. All right, so your ZIF socket or your CPU socket connects the CPU to the motherboard. Intel and AMD each have their own sockets, so you'll find that the motherboards differ for the Intel and AMD. This is SATA, Serial AT Attachment Port. It is used to connect internal storage devices such as hard drives to your computer. All right, so that connects, for example, your hard drive to your computer. That's your SATA. You can connect your CD-ROM as well, or DVD to your computer. This is your GPU/PCI Express. It's a high-speed slot used for the computer's graphics card. So you slot in your graphics card here. It's high speed because it sends and receives the most data. Your graphics card, because of its graphical display, sends and receives the most data. So this is a high-speed slot. Next is your PCI. These ones here, your PCI, your Peripheral Component Interconnect or PCI Express. Slots allow you to plug additional hardware like a graphics processing unit, sound card, Ethernet card, or Wi-Fi card into your computer. So you can attach other cards to your computer. Your motherboard buses. A bus is a communication system transferring data between components inside a computer or between computers. A bus connects components, provides power, and allows communication. Just to show you buses, and we'll go back to that slide, there's an example of what the buses look like. They're on your motherboard. Right, so a single bus can allow multiple simultaneous connections between components. So one single bus can have multiple connections between components. We have a point-to-point connection that's built into the motherboard and the CPU to allow them to communicate more easily. So your point-to-point connections are, for example, for your CPU and RAM, should be a point-to-point, so there is no other path. There's a direct connection between CPU and RAM so that the computer can work fast. There is no delay. Now, if you look at the other buses, they can transfer data between more than one component, but your point-to-point connections have a direct transfer between two components like your CPU and your RAM. The motherboard bus can be one of two types. We have the internal bus, which sends data and instructions to the different parts within the motherboard. It links different parts of the computer to the CPU and your main memory, which is your RAM. That's your internal bus. The external bus is the interface for peripheral devices like hard disks. So the bus that connects your peripheral, your add-on devices, like your hard disk, your CD drives, your flash drives, we have an external bus or expansion bus. The shape of each interface is unique, preventing one from plugging a device to a wrong port. So the ports are unique, so you'll be able to plug the devices in the correct port into a matching port. All buses have a control bus, a data bus, and a power bus. We also have an address bus that works with the data bus. A control bus, which is used by the CPU to send signals to the different parts of the computer. So the actions are coordinated. So you have a control bus that the CPU uses to send signals to coordinate activities on the motherboard. Your data bus provides a path to transfer data and instructions between components. But the data bus has to be assisted with the address bus, because the address bus provides the physical address of where the data has to move, of the data in the system memory or in the RAM. So the address bus has to provide the location of the data, and the data bus is carrying the data. The power bus, which energizes the different components of the computer system, so provides power for the components. The concept of modular design: computers are built using a modular design. That is, it is built from different components or modules. The reason for having different components will give you the advantages. Now, when you say different components, it means you can add a CPU or remove a CPU. The RAM can be changed. Your video card, you can add a video card, add a sound card, and so on. Now, the advantages allows you to update by replacing components with new components. So some components can be replaced. You can also easily replace or repair damaged components. It allows you to create thousands of different computers with different components, different speeds, and different abilities. By simply changing your CPU, your RAM, adding a video card, you can change a computer. If it's a gaming computer, we're looking at a GPU, a video card. If it's a home computer for home use, then you may not need a video card, and you can have less RAM. It all depends on what application you need your computer for. Remember the cost factor: the more components you add, and the higher powered components means more cost, increased cost. Now, for example, here you might buy a motherboard and then add an entry-level CPU, like an Intel Core i3. Then 4 GB RAM or a 500 GB hard drive. But you can use the same motherboard to build a gaming PC by adding more RAM, 1 or 2 GPUs, and replacing the i3 CPU with an i5 or i7. Now, CPUs can only be replaced if the motherboard allows that, the structure of the motherboard. Comparison between two computers: here's a basic computer, and here's your incredible computer that can be used for gaming. And here there's extra items like a liquid cooling system because of the heat generated from gaming, and the fast components, and 900 watts power supply. You're needing more power supply. You can see the difference in RAM. 1 4 GB RAM, here there's 2 8 GB or 16 gigabytes of RAM. And here we're using a built-in, for a basic computer, you have a built-in GPU, and here we have a GeForce RTX. And the speed of the processor, CPU 3.6, that's 4.7. And obviously with these components here being upgraded, the price will be much higher. The purpose and role of expansion cards. Expansion cards are cards that you're going to add to your motherboard. The PCI and PCI Express slots allow you to add or expand the features of the computer through the use of expansion cards, which you need to purchase separately. And examples of expansion card is your Ethernet, that's for your wired network, Ethernet card. Then you have your Wi-Fi card for wireless network, your sound card, your TV capture card, allows you to capture videos and store them on your computer, your storage controller, that allows you to add additional or faster hard drives. Next, we're looking at the flow transfer of data between components. Now, we spoke about there being 3 internal buses. We've got the data bus, the address bus, and the control bus. That's grouped as a system bus. The power bus transmits electricity, but these 3 work together for the data or for the processing that happens on the motherboard. So we need an address bus, we need the data bus, and we need the control bus. Your data bus is bidirectional. That means it travels in both directions since data is moving in and out of the processor. So if you look at your CPU, the data bus is bidirectional. See the arrow? Goes in both ways. Your address bus is unidirectional because it carries addressing signals from the processor to memory. Now the data has to be stored in memory. It has to be retrieved from memory. So it's one direction from CPU to memory. CPU to memory, the address bus moves. Your input-output peripherals and other addressable devices around the processor. So we also have input-output. But input-output devices are moving from RAM and to your device. So your addresses may go 2 ways. You're loading from RAM and you're going to store, for example, in a hard drive. So that will go 2 directions. But generally between CPU and memory, the address bus is unidirectional. The control bus are used to synchronize the activities. Some of these control signals are sent by the CPU to the other components to tell them the type of operation in progress. So the control bus is used to send control signals by the CPU to the other components, sent by the CPU to the other components. The I/O devices can also send control signals to the CPU, whether to read, write, or rest. So most of the control signals are sent by the CPU, but input-output devices can also send control signals to your CPU. The application, activity 1.2, page 9 from your DBA textbook. The next video will continue with hardware.